Hey guys, and welcome back. So in the previous nugget, we had talked about the init tab file, which is what the init process would originally consult when beginning to boot up. Within that nugget, however, we also mentioned the concept of some type of setup scripts. These are ultimately programs that run that will execute multiple commands or start multiple processes. And for the purposes of the LPIC2 examination, we have to understand what these boot scripts are and how they may differ depending on the type of distribution you have. Now, one thing to mention when we're talking about this, which is definitely relevant, is how sysvinit actually operates. So sysvinit is not the most efficient way to start up your system. And in fact, this is one of the reasons why sysvinit was ultimately replaced. But the way it would operate in a linear fashion. So what do I mean when I say linear? Well, it would start the init process, and it would help if I could write correctly, the init process. So that could be process number 1. And then after that was done, it would begin process number 2, whatever that may be, and then process number 3, and then number 4, and then number 5, and then 6. You kind of get the drift. After number 1 had kicked off and done its thing, number 2 followed, and then number 3, and then number 4, number 5, and when you happen to have lots of processes that have to be run, this is quite slow, quite sluggish, and definitely inefficient, so just something to be aware of. This is how the process actually happens when you're using a sysvinit system. Now, how does sysvinit determine which processes to run and in which order, i.e. what should I run and what should I run first and then second and then third, and not just in some random order, because of course certain processes rely on other processes, so the order is indeed important. Well, this is what we want to talk about primarily in this nugget right here. We have two different locations where init is going to look. If we happen to be looking on a Red Hat based distribution, the location is going to be different than if we are looking on a Debian based distribution. So if you happen to be using a Debian based system, the location where the init process is going to look in the etc directory and then the init.d directory. However, if we happen to be using a Red Hat based system, again we look in the etc directory, but we then look in the rc.d file, or rather rc.d directory, my apologies. So let's talk about two important scripts that you would find on a Red Hat based system. So the first script I want to talk to you about is in the etc directory. We know it's going to be in rc.d because we're talking about Red Hat systems, and the first script is going to be rc.sysinit. Now what this one is all about, it's designed to effectively load the system to a very simple state that is quite honestly the same as run level 1, a single user mode. And all this script is going to do, it's going to perform actions such as mounting file systems and enabling devices such as RAID devices and logical volume manager, and starting up some essential system services. Now, for real world purposes, this script right here happens to be what is known as a bash script, i.e. it is written using the Born Again shell. And you are very, very unlikely to modify the contents of this bash script. But as an administrator, you may have to be able to look into this file and do a little bit of detective work in the event that you have some issues booting up your system. And the next one, again, in the etc directory, it's going to be in rc.d, and this one is just called rc. Now, whenever we are on run levels 1 to 6, this script is going to be executed. Now, this script itself will not do anything on its own. You actually have to pass a particular value to this script, such as 1 or such as 5. Recall what we saw in the init tab file in the previous nugget. Within this file here, this is where you would specify a particular argument. Now, what this actually means, say for example, we had L3, which would be the ID, and then run level 5, and then the wait action, and then we could specify etc rc.d.rc, and then we could provide an argument, number 5. We're basically given the argument 5 to this script. For run level 5, we're going to use the wait action, i.e. allow it to complete. And this script is ultimately going to find additional script to help us load into the correct specified run level, in this case here, run level 5. We will actually find directories within this directory, and it's going to follow a very particular format. The format would look something like, say, this: rc0.d and rc1.d and maybe rc5.d. You get the drift. These are directories which actually correlate to a particular run level, i.e. within this directory here, this would be files relating to run level 0, whereas in rc5.d, this would be a directory for run level 5. Now, within these directories, what you're going to find are symbolic links. Now, these symbolic links ultimately relate to the starting of processes as well as the killing of processes, which might sound a little bit dramatic, but ultimately starting processes and stopping processes. Now, these symbolic links are going to follow a very particular format. If the symbolic link happens to begin with an S, then this is going to point to a process relating to starting a process. And if the symbolic link begins with a K, you can guess this actually relates to killing processes. So all these symbolic links do is they point to scripts, and these scripts handle these tasks, i.e. starting things or stopping things. So if we happen to see a symbolic link which was K, and then maybe the number 9, and then maybe, I don't know, Nginx, we can infer by the formatting of this symbolic link of what it's actually doing. We see a K, so we know this sym link is pointing to a script which is going to kill a particular process. We get the number here, which is the numerical number. Remember, sysv init operates in a sequential manner. Process 1 will go before process 2. In this case here, we have process 9, so after process 8 begins, this particular one will execute, and it's going to kill the Nginx process. So like I say, on modern systems, the sysv init program is ultimately outdated and has been replaced with systemd. But nevertheless, we can get a rough idea of what this looks like even on a modern system. So what I'll do is I'll go into the etc directory, and if I happen to go into maybe say rc3.d, what this is scripts relating to run level 3. Whereas if I happen to go in, let's say rc5.d, this would be scripts relating to run level 5. Now if I do an ls, we can just see a whole bunch of what are symlinks. If I do an ls-l for the long listing, we can actually see where these symlinks are pointing to. Now notice, because this is a Debian based system, these are actually pointing to init.d, whereas this would be different within a Red Hat based system. Now notice we have the value k. This means that this is relating to killing processes, whereas the other ones here, these are all beginning with S, these are for starting processes, and the next one is the value, the process number. Now you might notice that these all appear to be starting at the same time. We are now on a modern systemd based system, and things can actually operate in parallel, so we're no longer hamstrung by the older implementation of sysv init. So that is what I'm saying, that the example here is not exactly perfect because we are talking about older, outdated technology, which frustratingly is still a big part of the LPIC 2 examination, of course. But that is what you're seeing when you see these discrepancies. We are ultimately mapping old technology onto new technology. So if I happen to open up one of these scripts right here, so I'll say nano so1 acpid and hit enter, what you are looking at here is a bash script. This is ultimately just a file full of programming logic to do certain things, such as loading particular modules and starting and stopping particular processes, so on and so forth. And ultimately, this is what all of these files look like. They're all bash scripts. Again, we go into maybe say S1 cron, same type of deal. We are just running a script to stand up the cron service. So a whole bunch of programming logic within here. Now, if we wanted to control a particular action, maybe we wanted to change the rsync from starting up, what we could actually do is we could rename the sym link. Now the sym link happens to be S01 rsync. What if we happen to change that? So I said S01 rsync, and I changed it to K01 rsync. What I need to do, of course, is to do super user privileges because I'm in the etc directory. Let me just type in my password. And now if I do an ls-l, we can see here rsync has a symlink beginning with K. So what this means is that when we happen to drop into our particular run level, this is run level 5, instead of starting the rsync program, we would happen to stop it. Now the issue here is that whilst we can manage these processes, we can ultimately invoke scripts to start or to kill particular applications and actions. This is not the most friendly way to manage such a thing. Just by renaming symlinks, things can be confusing. And by the way, on older systems whereby we had to use this particular action, i.e. when we were using sys v init based systems whereby the processes were not parallel, they were sequential, and the order of operations mattered much more. By renaming symlinks, if we happen to maybe use the wrong number, we could actually change the order of operations, and if some processes relied on another process standing up and we got the order wrong, then well, we could definitely cause some issues. But the good news was, for systemd based administrators, they did actually have the ability to use some particular tools to simplify this action. Now, what exactly were those tools? How were they used? Well, that's what we're going to be talking about in the very next nugget. So I hope this has been informative for you, and I'd like to thank you for viewing.